We're talking about the cosine addition formulas, and I want to prove the first one, the cosine of a difference. Let's take a look at the unit circle. I have two angles drawn here, angle alpha and angle beta. And you remember that in order to find the sine or cosine of either of these angles, I would need the coordinates of these points. So, for example, for alpha, I would need to know the coordinates of point A. The first coordinate, cosine alpha, this tells me the cosine of the angle, and the second coordinate tells me the sine of the angle. And down here, for point B, the first coordinate tells me the cosine of the angle, and the second coordinate gives me the sine of that angle. What I'm interested in finding out is, can I use that information to find the cosine of beta minus alpha, this angle? And it turns out that you can, although the proof is a little tricky. So here's what I want to do. I want to first find this length AB. And I'm going to do it using the law of cosines. Let's take a look at the law of cosines. Got it written way over here. So you'll recall that when you have a triangle labeled like this with sides ABC, and C is opposite the angle theta, C squared equals A squared plus B squared minus 2AB times cosine theta. So you'll recall it looks a lot like the Pythagorean theorem, only you've got this little correction factor here, minus 2AB cosine theta. We're going to use this right now. So let's find AB. We'll actually find AB squared, right, in this triangle. So our theta is going to be beta minus alpha. These are the two sides A and B. And by the way, we're in the unit circle, so both of them have length 1. And this is the side length we're going to find. So AB squared equals 1 squared plus 1 squared. That's the sum of the squares of these two sides. And then I subtract twice the product, 2 times 1 times 1, times the cosine of the angle between them, and that was the cosine of beta minus alpha. So just simplifying, I have AB squared is 1 plus 1, 2, minus 2 cosine of beta minus alpha. Okay, that's a start. Now let's take a look back at the unit circle. I can also find an expression for this distance using the distance formula, right? Now the distance formula kind of works like the Pythagorean theorem. It's based on the Pythagorean theorem. The distance formula by itself would give me the length AB as the square root of the difference in x coordinates squared plus the difference in y coordinates squared. So the difference in x coordinates is cosine beta minus cosine alpha squared plus, and the difference in y coordinates, sine beta minus sine alpha squared. Of course, I want to equate these two in the end, so I'm just going to square this. And that'll give me cosine beta minus cosine alpha squared, and sine beta minus sine alpha squared. Let me expand these two. Right, it's just binomial expansion, even though the actual terms in the binomial are kind of ugly. This is not too bad. It's cosine squared beta minus 2 cosine beta cosine alpha plus cosine squared alpha. That takes care of this part. Now let's do this part. Sine squared beta minus 2 sine beta sine alpha plus sine squared alpha. All right, let's stand back, because that looks like a mess. We have a cosine squared beta and a sine squared beta. These two together make 1. So equals I'll color code this, 1. But we also have a cosine squared alpha and a sine squared alpha, and those two together make 1. So I have 1 plus whatever's left, and whatever's left is the minus 2 cosine beta cosine alpha and the minus 2 sine beta sine alpha. Right? This is 2 minus 2 cosine beta cosine alpha minus 2 sine beta sine alpha. Now, the plan was to set these two equal to each other, right? Both this quantity equals ab squared and this quantity equals ab squared, so they must equal each other. And so I pull this guy in and substitute it in on the left, and I get 2 minus 2 cosine of beta minus alpha equals 2 minus, and I'll factor the 2 out, 2 cosine beta cosine alpha plus, if I factor the negative 2 out, I'll be left with plus sine beta sine alpha. And do you see what's happening here? You've got 2 minus 2 times something equals 2 minus 2 times something else. The somethings have to be equal, and that gives me the final formula, cosine of beta minus alpha equals cosine beta cosine alpha plus sine beta sine alpha. This is the cosine of a difference formula.